All right, let's talk about one of the biggest, most mind-bending questions out there, the Fermi Paradox. Simply put, if the universe is as massive as we think it is, why does it seem so empty? Let's jump right into this incredible cosmic mystery.
It really all comes down to this one simple and honestly kind of haunting question. The numbers, the sheer scale of everything, suggests that the universe should be absolutely buzzing with life. But when we point our telescopes out there and listen, all we get is static, silence.
And this is the heart of the problem, right here. On one side, you've got the mind-boggling scale of it all. Billions upon billions of stars just like our sun, many of them way, way older than we are, so life should seem almost inevitable. But on the other side, you've got our reality here on Earth. Zero, zilch, not a single confirmed piece of evidence of contact. It's this huge contradiction that has kept scientists up at night for decades.
So let's really frame this up. This isn't just some late-night philosophical question. Nope, this is a real scientific puzzle, first brought up by the brilliant physicist Enrico Fermi. It's basically an argument between what probability tells us should be happening and the silent reality we actually observe. This really nails it. The paradox is this giant clash between the super high odds of alien life existing and the absolute, deafening silence we get from the cosmos. The math says they should be here, but all our evidence says nobody's home. So, where did we get our math wrong? Or is something else going on?
Okay, so let's walk through Fermi's logic. It's a pretty straightforward chain of thought. You start with billions of stars that are a lot like our own sun. A good chunk of them are billions of years older, giving life a huge head start. So it's pretty likely they've got Earth-like planets, right? And from there, it seems reasonable that some of those would develop life, then intelligence, and eventually the tech to travel between stars. Now here's the kicker. If just one civilization did that, they should have colonized the whole galaxy by now. And yet, we see nothing, which leads us to one of the most popular and kind of scary potential explanations. It's a concept called the Great Filter. The idea is that there might be some massive, almost impossible barrier that stops life in its tracks, preventing it from getting to where we are and beyond. To really get the Great Filter, we have to go all the way back to the very beginning of life itself. That moment is called abiogenesis. It's the spark, the jump from non-living chemicals to actual life. It's one of the biggest mysteries in science. And what if that's the Great Filter? What if that leap is so fantastically, absurdly improbable that it's only ever happened once? And where it's? Scientists think about the origin of life as happening in roughly 3 stages. First, you need the basic organic building blocks. Think of them as life's Lego pieces. Then, those pieces have to link up into long, complex chains, like DNA. And finally, those chains have to somehow come together and evolve into a cell that can actually copy itself. A failure at any one of those steps, and poof, no life. Could one of them be the universe's ultimate roadblock? So the bottom line is this. The Great Filter idea suggests that somewhere along the line from primordial ooze to a galaxy-spanning civilization, there is a wall that is nearly impossible to get past. And the truly terrifying question for us is that wall behind us in our evolutionary past, or is it still waiting for us up ahead? So how in the world do scientists even begin to think about this stuff? Well, they use a kind of mental tool, a way to structure the problem. It's not about getting an exact answer, but about asking the right questions. It's called the Drake equation. Now, don't let the math scare you. The real point of this equation isn't to spit out a perfect number. Its purpose is to take the huge, overwhelming question, are we alone, and break it down into smaller, bite-sized pieces. You could say it's a way for us to organize our own ignorance. Okay, let's unpack this thing. The equation starts with stuff we actually have a decent handle on, like how many stars are forming and how many of them have planets. Thanks to telescopes like Kepler and the James Webb, we're getting pretty good at estimating those. But then it dives into pure guesswork. What fraction of planets actually develop life? Of those, how many become intelligent? How many start sending out signals? And maybe the biggest question of all, how long do those civilizations stick around before they go silent? Any one of those last few variables could be so close to zero that it answers the paradox all by itself. So after we've looked at the paradox itself, a possible filter, and the equation we use to think about it, we end up right back where we started. We're left with this profound unanswered question. What does all this silence actually mean? And here's the puzzle laid out plain and simple.
Is the universe's quiet telling us that one of those steps to intelligent life is a nearly impossible barrier, a great filter we somehow managed to pass? Or is it because one of those variables in the Drake equation, like maybe the lifespan of a civilization, is just tragically short? The silence could mean that life is an extraordinary fluke, or that intelligent life is exceptionally good at destroying itself. So in the end, that's what we're left with. What is this vast, empty-seeming universe trying to tell us? Is it a sign that we're the first ones to the party? Is it a chilling warning that a great filter is still waiting for us, one that no one else has survived? Or, and this is the hopeful one, is it just an invitation to be patient, to keep looking, and to keep listening? The answer is still out there, somewhere in the silence.